In the year 452, the Roman Empire is nearing total collapse, and the Huns have begun their assault on northern Italy. Many towns are wiped out entirely, forcing residents to flee for their lives. Seeking safety, they move toward a coastal lagoon and settle on a handful of tiny islands, a choice that, without them knowing it, would save them. Against every expectation, this small group of refugees would go on to create one of the most remarkable engineering achievements in history, the city of Venice. Even though they had no proper roads, little solid ground, and no natural fresh water, the Venetians transformed a muddy marsh into the richest and most powerful city of its age. Its network of canals and bridges, stretched across hundreds of islands, made Venice incredibly easy to navigate and turned it into the center of trade. We rebuilt the entire system to show what lies underneath the city and how its smart design and medieval engineering enabled it to rise above the rest. When the first settlers began building their new homes, they were met with terrible terrain. The small marshy islands were made of extremely soft clay that couldn't support even a person's weight, much less a whole city. To create stable foundations, the Venetians cut long wooden piles from the forests of Croatia and drove them deep into the mud. Each pile was hammered about 5 meters down until it reached a firmer layer of clay. This not only stabilized the piles, but packing them close together compressed the surrounding soil, squeezing out water and making it stronger. Once the piles were firmly set, their tops were trimmed and covered with wooden planks to spread the weight. Blocks of sturdy Istrian stone were then added on top to raise everything above the waterline. This was a brilliant approach. Because the wooden piles were sealed underwater and protected from oxygen, they could not rot. Remarkably, most of these ancient piles remain in excellent condition today and still support the city. After the foundations were secure, the Venetians could construct their buildings. They first relied on wood, but after several fires, they shifted to brick. To keep structures light, buildings could not exceed 3 stories. Lime mortar, instead of cement, was used because its flexibility allowed the walls to move slightly as the ground slowly shifted. Interior walls were arranged in a crisscross style so they could bend like a lattice. Exterior facades, decorated with stone and large windows, were much heavier. To prevent them from leaning or collapsing, iron rods were installed into the ground to hold the entire structure together. This technique proved effective, and soon many islands across the lagoon were built using the same method. Instead of spreading outward like normal cities, these islands gradually grew toward one another. In the beginning, boats were the only way to travel between the islands. Over time, as the islands expanded and the water between them became shallower, people could even ride across on horseback. The next stage in Venice's growth was to physically connect the islands. Surprisingly, Venice had no bridges for its first 5 centuries. But as the population grew and trade exploded, the city needed more direct access to the Rialto, its financial heart. To transition Venice from separate islands into a thriving city, bridges were essential. The first solution was a simple, floating pontoon bridge linking the 2 largest islands, allowing quick passage to the Rialto market. This was later replaced with a wooden bridge, which eventually burned down and later collapsed. Finally, a much stronger stone bridge was built. More than 12,000 wooden piles were driven into the canal banks, and around 10,000 tons of stone were placed above them to complete the structure. That stone bridge still stands today and remains the main passageway through central Venice. Afterward, stone bridges began appearing all over the city, turning Venice into a compact urban center, built entirely around canals rather than roads. This gave Venice a major advantage. Goods and people could move swiftly without the typical congestion caused by pedestrians and horses sharing the same paths. Walkways and waterways were fully separated, allowing smooth travel throughout the city. By this point, Venice had become the wealthiest and most influential city in Europe. Nearly all trade passed through its ports, generating immense profits for the Venetians. But with increasing commerce came a rising population, and the demand for fresh water became unmanageable. Although surrounded by water, none of it could be used because the lagoon was salty and unsafe to drink. With no rivers or natural springs, Venice relied on boats to bring water from the mainland. But with 170,000 residents, this was no longer enough. Engineers had to design a new solution. The idea was to turn the city squares, originally open fields used for grazing, into rainwater collectors. Workers dug out large chambers beneath the squares and lined their walls with thick clay to seal them. These pits were filled with sand and stones, and the surface was rebuilt with tiles that sloped toward drains at each corner. Rainwater would run into these drains, pass through the filtering sand and stones, and collect in a central well. To capture even more water, rooftops around the square were fitted with gutters directing runoff into the same drains. Every square became a massive funnel, filling more than 600 wells across the city. Once again, Venetian creativity saved the city, but one major problem remained: waste. Until then, people simply tossed their waste out of their windows, some of it landing in canals. Others, who lived farther away, left urine, feces, and spoiled food in the streets. In the 16th century, Venice built an underground tunnel system that carried waste from every building into the canals. When the lagoon's tide was low, solid waste settled in the tunnels while liquids drained into the water. As the tide rose, the tunnels flooded and washed the solid waste into the canals. The twice-daily tide cycles replaced dirty water with cleaner seawater. The lagoon's high salt content acted as a disinfectant, keeping the city cleaner than expected for the time. Amazingly, Venice still stands strong today, a city that has endured for centuries and continues to captivate the world. Its canals, bridges, and remarkable engineering remain a testament to human creativity and determination, drawing millions of visitors every year who come to experience its beauty firsthand. If you enjoyed this video and want to see more content like this, make sure to hit the like button and subscribe to the channel. Your support helps us bring you even more fascinating stories from history and engineering. Thanks for watching, and we'll see you in the next one. Goodbye.